The final topic in integration is integrating sin x and cos x. So if you think back to the differentiation topic, you might have been told about Snapchat. So remember, Snapchat is SC, so Snapchat, and your bottom two are negative. So remember, this is just a helpful way of remembering how you differentiate and integrate. So if you differentiate, remember differentiating involves decreasing a power, so you would be going down the way. So if you differentiate, you decrease from sine down to cos, down to negative sine, down to negative cos. If you're integrating, you would increase your power, so you would go up the way. So that would be if you were integrating. So that would be helpful just to help you remember which one you're changing it to. So your rules appear on your formula sheet. So obviously you can refer back to there, but just notice that the difference between the differentiation rules and the integrating rules is that you now have to divide by the derivative of your bracket, as we've seen in the composite functions integrating lesson. So here are some straightforward examples to start off with. So I'm going to set myself up with my Snapchat at the side. So looking at this first example where I've got 2 sin x dx. So if I'm starting at sine and I integrate it, if I integrate it means I increase, I go up the way. So in this case, remember that this is actually continuous. So if I wanted to, I could keep going with this and just keep writing out my Snapchat. Right? That means that in the case up here where you've ended up with nothing above it, you can maybe refer down to this one here. So if I've got sine and I integrate it, it means I increase it. So sine becomes negative cos. So that would become negative 2 cos x plus c. So the next one wants me to integrate 5 cos x dx. So again, I'm looking for a cos. So here's a cos down here. If I'm integrating, I'm increasing, so I'm going up the way. So cos x integrates to sin x. So that would be 5 sin x plus c. Next one, we've got negative 3 sin x dx. Now for this one, rather than looking for sin x, we are looking for a negative sign. So over here, I've got a negative sign. If I integrate, I go up the way, I increase. Negative sign becomes positive cos. So negative 3 sin x would integrate to positive 3 cos x. And then remember your constant of integration at the end. Similarly, on this last one, we're starting off with negative cos x dx. So if I look for a negative cos, here's negative cos here. Integrate, go up the way. Negative cos goes to negative sine. So that would be negative 6 sin x and plus c at the end. Now, you might need to add some of these into your notes, but we need to look at what happens when your number is in a different position. So for example, with that first question, we've got 2 sin x. However, that would be treated differently to 2 sin x dx. Okay, so this is where your composite function comes in, and this one would be the most similar to the one that you're given on your formula sheet. So remember that 2x is actually a 2x in a bracket, but we don't always write that bracket out. So if the number comes before the sine or the cos, then it's just a constant, it just stays there. But if it comes after the sine or the cos, we have to deal with it. So what I mean by that is if we have sine, we're starting off with sine, so here's a sine over here. If I integrate sine, I increase up to negative cos. So sine 2x dx, integrating it, I get negative cos 2x. But remember, I also have to divide by the derivative of the bracket. So if I differentiate 2x, I just get 2. So I need to divide this by 2. And then I've got my plus c. Now, just to make it look slightly neater, I'm going to write that out as negative 1/2 cos 2x plus c. Let's look at another one. So if, for example, over here, rather than having negative 3 sin x dx, say we had negative 3 sin 4x dx. So remember that the number in front of your sin x or cos x, that is just there as a constant. That's just going to follow you through. That will be part of your final answer. This 4x, So anything that comes after the sine or cos, although we don't write it, it is always in brackets. That is something that you're going to have to deal with. It's something that you're going to have to differentiate. So take this step by step. So looking at the fact that I've got a negative sine x, so if I go over to my negative sine x, so if I go back here, if I integrate negative sine, I move up and I get positive cos. So negative 3 sine 4x dx will start off with 3 cos 4x, because that 3 has to stay where it is. The 4 also has to stay where it is to start off with, but then we have to deal with the 4. So remember, because we're integrating, we now need to differentiate the bracket and divide by that. So differentiate 4x, we get 4. So we're dividing by 4 and we're adding on our constant of integration. And again, just to make it look slightly neater, I'm just going to write it as 3/4 of cos 4x plus c. So moving on, we've got some more examples over here. So anytime you see sine or cos and you're looking to integrate or differentiate, first thing I would always write out Snapchat. Remember the bottom two are negative. So looking at this first one, we are integrating sine 4x minus 3. So this one, we have clear brackets in it. So it's much like the examples that I added in the last one. It's just that we're given our brackets, so we're less likely to forget them this time. So I'm going to start off by considering what happens to sine when I integrate. If I start at sine, if I integrate, I increase. And remember, what that essentially does is it gets me back to this negative cos. So this is going to go to negative cos. My bracket has to stay exactly where it is. But I also have to deal with this bracket. And remember, to deal with the bracket, you divide by the derivative of the bracket. If I differentiate 4x minus 3, I get 4. And then remember my plus c. And as always, just because it looks a little bit neater, I'm going to write that as negative 1/4 cos 4x minus 3 and plus c at the end. So this next one, we have got a definite integral. We've got a cos 3x, so this time my 3x is following my cos. So remember, that's actually got brackets in it that we have to add in ourselves just to remind ourselves that it's there. So I'm going to start off by integrating. This time I'm going to have to put it in a square brackets because it's my definite integral. I've got a cos. If I start at cos and I integrate, I go up to sine. So cos 3x becomes sine 3x. But remember, we need to deal with that bracket. And to deal with that bracket, we divide by 3, which is the derivative of the bracket. And we're going from 0 to pi over 6. So that means that I have to do 1/3 of sine 3 times by my upper limit. So I've got 3 times by pi over 6 minus 1/3 of sine 3 times by my lower limit, which is 0. That then gives me 1/3 of sine. So if I've got 3 times by pi over 6, that's the same as 3 pi over 6, which would simplify to pi over 2, minus 1/3 of sine 3 times 0 is just 0. So I've got 1/3 times by sine of pi over 2. So if you're familiar with your radians, you can use your exact values using your radians, or I prefer to do it using degrees. So pi over 2 is 180 over 2, which gives me 90. Sine of 90, thinking about my graphs, it's up at 1. Minus sine of 0 is just 0. So we're taking away 0. So we've got 1/3 times 1, which is just 1/3.